The stuff of the visible universe, stars, planets, people, are a cosmic afterthought. Just a luminous sprinkling on top of the vast oceans of dark matter that dominate the gravitational universe. Although we don't know what dark matter actually is,
weird,
for a long
robots.
time we thought that we at least had its behavior nailed. The so-called cold dark matter model had to be right because it worked so well in explaining structure in the universe. Well, that is, until it didn't. Distressing disagreements with newer observations sent many physicists back to the blackboard. But even more recently, a new generation of sophisticated
Time is not a
high-powered
particle.
computer simulations
But are you looking at your charts
may
right
save
now?
our favorite dark matter model after all, with some unexpected
It's
help.
a fourth, fifth
It turns
dimensional
out that
calculation. It's a
visible
third,
matter
fourth,
may
and
be
fifth
much more
dimensional
important in
calculation
shaping
all
the
at the same
universe
time,
than we ever imagined.
which makes it a one-dimensional, two-dimensional line.
We
It's
have
got
no
ups and
idea what
downs
dark
over a
matter
line,
is,
which
other
X and
than
Y
it's
on
some
Born
sort of
Identity
gravity
for the
that
black
is
body
completely
problem.
invisible,
But at any rate,
but exerts way more pull than all of the regular matter. More than
you
all
go
of the
on,
stars,
General.
all of the gas,
You go
all
on.
of the black holes. Unless dark matter is black holes, then black holes are most of everything.
I'm going to argue with him
But
a
dark
little
matter
bit here,
constitutes
because he's
80%
saying we
or
don't
so
need it. It was
of
like,
the
I
mass
use
of
it
the
I hat.
universe,
My
which
dark
means even our Milky Way galaxy is
matter
mostly
model
a
is I hat.
vast ball of dark
J
matter
hat, dark
that
energy,
happens to have attracted a
where
relative
3
sprinkling
pi,
of baryons,
3.14 pi,
atoms in
and
the
4
form of
pi
gas, which
in
lit
that
up into
that
a
system, which
starry
makes
glitter
it 3,
spinning in the middle
a
of
fourth,
this invisible
or a fifth, or a
gravitational
three-dimensional
well. But for all of
3.14,
dark matter's
5. It
mysteriousness,
points
it's remarkably
left of
simple
him,
stuff in terms
right
of its
of him,
behavior,
up
or
of
at
him.
least so we have long thought. The mainstream model for dark matter is called cold dark matter, or
Alright,
CDM.
so I'm going to give you something practical.
This
I'm going
type
to
of
give you a
dark
little
matter is
marshmallow to
described
chase
as a
around
fluid
tonight.
of particles that don't
If we haven't
interact
been
with
doing
each
the bit
other
farm.
or anything
You know,
else
because
except via
this
gravity,
is the only thing running
and that
24/7 really that I big enough where I'm going to say I feel safe about
such a fluid.
what
Any
when you
tiny
look through
lumps in
James Webb, you're
density of that
actually
fluid
seeing
tend to
before the
attract more dark
computers
matter and
take
grow.
the
We can now do
ultraviolet
these
spectrum
incredible
into
supercomputer
consideration
simulations of this
about
process,
some
and based on
lensing
the
feature
CDM
that
model,
didn't
this
lens
type of
so
dark
well
matter
inside
seems
of
to
there.
lead
Well,
to
it's
exactly the types
dark
of giant
matter
structures,
that's
galaxies,
mattering
galaxy clusters,
and some
etc.,
weakly
that we
attracting
see
or
in the
strongly
universe today.
attracting.
Although we don't know
I know,
what
right?
this CDM might be made
But
of,
anyway, it's
there are
weakly
some
attracting
seemingly
and
very
strongly
plausible types of
attracted
particle that could
to
do
the
job.
system.
Broadly, we have
Sometimes,
weakly interacting
because
massive
these drop
particles,
down,
or
that does
WIMPs,
that, which gives
which
it
are
an
predicted by
a
various
counter.
extensions
You'll
to
see
the
them do
standard model of
this,
particle
A,
physics. Or there's
B,
another exotic particle, the
A,
axion,
B,
or even
C,
maybe frozen
A, B,
Planck
you
scale
know,
relics
depending
of
on how
evaporated
you
black
were
holes.
reading it.
These
And so you see
all
how
behave
time is that
like cold
particle
dark matter,
that
and we've talked
created
about
this
all of them
lensing
before.
effect,
The
but
fact
not
that there are
really
many fairly natural
lensing.
ways
There's
to make
gravity to
cold dark matter
this
is a point
that
in favor of the
says
idea.
if you put
But
space-time
another
guy
one
behind it, his
is the
shine
so-called
is just gonna
miracle.
blow right through.
Most elementary particles in our universe were created soon after the Big Bang
Anyway,
during a short period
take a
when
look.
the universe was
Let's
hot
take a look.
enough
Let's
for
play a
matter
marshmallow,
antimatter
guys.
pairs to be
Let's
created
look in here and
spontaneously from the extremely energetic
play
radiation of that
a
time.
marshmallow.
That creation process stopped when the universe expanded.
Now, from what I
and
know about
cooled,
paper trading during
and
the day,
most of this stuff
this
annihilated
sequence
with
gets me
itself.
in there in
Regular
time,
matter,
but
which is
you
much
got
more
some
able
choppy
to
spots.
interact with itself,
You know, right now we're pretty
almost
good. This
completely
is not actually the
annihilated.
HUD I like to
So
use.
that the matter
Shut
that
up.
was left
She's
is
rolling
just due
down.
to the
Let's
1
see
in a
what else we
billion
got here.
overabundance
I hate
of
this
normal
chart.
matter over antimatter. But dark matter particles in the WIMP category wouldn't have self-annihilated so quickly due to its weakly interacting nature.
See?
Instead,
It's gone.
it stopped
There was a
annihilating only when
weekly
the universe
dark
got
matter
too big for
calculation,
dark matter particles
fiddling
to
around
find
with the
each other.
photoelectric effect.
It turns
Put
out,
the time down.
If you calculate how much
If
dark
you
matter should have
calculated
been left when that
all of these little
annihilation
tiny
stops,
averages where you just
you get
lost it,
pretty much
that's
the
a
right
WIMP
number
particle.
for the amount of dark matter
This
we see in the
holy WIMP
universe
thing where it's
today.
like, I don't know,
And
some
that's the
Rain
WIMP
Man
miracle.
thing coming
Now,
in here.
This does require
But I had the
existence
J
of some
hat for the
unknown
chemistry.
heavy non-standard model particle like
Is-
those predicted by supersymmetry.
This
But actually,
was
the WIMP
water in
miracle is
solution
not
in
tied to
a
any
graduated
particular
cylinder.
theory.
It's
Long
at sea
story
level.
short,
Nobody cares.
CDM
Don't even look at
was
this yet.
looking great.
It
But then, starting around
the
20
sun
years
came
ago,
on it,
we began
it started to
notice
heat
our
up.
rapidly
That
improving
temperature
simulations
right there
and
changed it. Now,
observations of the universe
add chemistry,
stopped
add
matching up quite so
sulfuric
well.
acid, and a
Let's
piece
start
of
on the
copper.
simulation side.
At a baseline of this triple
Because
point,
dark matter is
it
cold,
doesn't fizzle
you should
over
be able to
because
form
the
pretty
ambient
small
temperature,
blobs
or you
with
expected an
relatively little
exothermic
gravity holding
reaction
them together.
that says,
That's because
okay,
the
so if I
cold
add
means
that amount
slow-moving
to this
particles,
position,
which have trouble
it will
escaping even
do
with
this.
gravitational
And as
fields.
long as that is the overall
So if we try
average,
to
it'll do
simulate,
that.
say,
So you
the
get into
formation
this
of the Milky
immediate
Way
fractal about
with
what
this
happened.
type of dark
But the
matter, we get
observation,
something
a
weird.
dot on a
We
line
get a big
of
dark
what it
matter halo
is,
that attracts the gas and forms the stars
and what
of
it
the
was
galaxy.
is I hat and
That
J
part is
hat.
fine.
The
But
mechanics
within its
here,
halo, these CDM simulations
high on the signal,
also
is
predict
orbitaling
a lot of subhalos,
some kind of
smaller
function. It comes
dents
up, it
in
comes
the big
down, it gains
gravitational
intensity,
well
it
that
starts to catch, it
themselves
picks
should
up,
presumably
and runs.
attract
Again, this
gas
is bit,
and
so
form
it's a
sort of
weird little
mini-galaxies, what
microcosm
we
where
call
you gotta be
satellite
careful with it.
galaxies.
But fundamentally,
simulations
from those
predicted the Milky
initial
Way
big
and really any
bangs,
big galaxy
before it
should be
blows out
orbited
and
by
goes anywhere, so what we're
thousands of
saying
these
is that
things.
ran this kind of
But
45, which isn't
our
horrible, really. I
observations of
mean,
real galaxies don't
it seems
find
tight when you
anywhere
look
near
at it
enough
like
of
that. But
This is
because
the
they
missing
oscillate,
satellite's
this is
problem,
low
and
entropy,
it was a clue
high
that our
entropy,
CDM
low
model
entropy,
might not be
with
as
low and high
miraculous as we
entropies in
once
there.
thought.
If you
Another
didn't really get
prediction
that
of
combination,
the cold
plus
dark
the
matter
weights
model
and
is about
plates.
the shapes of big
Alright,
galaxies.
here's another example for you.
Gas in a room
that out of here. I don't
pushes
want
on
that one.
itself due to the fact that the
You could
particles
use that one.
interact,
1, 2, 3.
creating an outward pressure.
Let's do
But
that,
the
actually.
weakly interacting CDM particles don't push each other
Let's do
apart.
that.
Add the fact that they are moving very slowly, and it becomes possible for these particles to form very dense
Something at any rate.
clusters.
Zoom in on
CDM
it.
models predict that
When I'm looking for
inside
quark
galaxies,
states,
the density of dark
say
matter
it's those three.
should go up and up as you travel from the
Here's
outskirts
a version
inwards,
of the diagram.
and it should reach
This
a very
is
high
one of the
density
things, no matter
cusp
where that
near
is on the
center.
mountain, it's going to
And
predict some
regular
things.
matter
Now
should
later
flow
on, that
towards
time
this dark
particle,
matter
the
concentration,
supersymmetry scale
resulting
of
in
the
lots
resonance
stars near the
frequency on
galactic
this
center.
is going to send
But
it
in real
right there.
galaxies, the density usually
At least that's what I
flattens
keep
out within
seeing
several
when
thousand
I'm
light
putting
years
in
at
these
the
bets.
center, leaving a more
The hard
rounded
thing,
core.
it is big
This
up
is
or
known
big
as
down,
the cusp core problem,
right? You
and
know,
it's
right
the second
there,
strike
I
against
missed this
cold
one. I
dark matter.
wanted to put it in this one. I've been
Of course,
playing it,
physics
I set it
thrives
in
on
there. I
discrepancies,
didn't get
and these
over it.
problems
It
have
broke
inspired
down.
many
I
years
don't
of
want to put
work
into
on
this because it's about to.
alternatives
And even if
standard
it shot up,
CDM
I don't
model.
care.
The
That
most
I could
obvious fix
don't
to
care.
cold
Don't.
dark matter is to change
ridiculous.
the temperature.
So
Change
he'll get chopped
cold
up in
matter.
here a little bit.
We can't heat up dark matter.
That
too
diagram's
much or its
tough.
particles won't
You know,
form
this one's
halos
open,
at
that
all.
one's
They'll
closed,
just
and
whiz
you know
randomly
we got a
through the
trending
universe and be
down.
pretty useless. But what
Trending
if we
double
increase the
down,
temperature
light
just a
down
bit?
by a
Give
degree.
us
I
more
bring
dark
that up
matter,
because
or WDM.
not only do you have
There is a way to
open,
do this. Sterile neutrinos
you have
would give us
this
a
closed
WDM,
effect when they're in there,
and we've discussed those
like they are like
previously.
this right now. What
However,
does that mean?
These weird neutrinos abundance doesn't miraculously
always
come
do
out
that?
from the particle physics and the cosmology
Well,
in the
not
same
quite.
way that WIMPs seem to.
So it's a little
If dark
forward,
matter is
and then
made
this
of a
one was on
relatively
it. That
light
was the
particle that has
initial
a
little
slightly
run
higher
up
temperature,
on it. Well,
then
why
they
didn't it go
can
up
still
or stay
form
flat,
weak
right?
halos,
You asked this
but they
weird
have a harder
question.
time
Well, that's
forming
how
these
math and
subhalos.
universe, dark
That's simply
energy and
because
dark
small
matter
halos
expand
don't
and
have strong
contract
enough
this,
gravitational
at
fields
least as far as
to
I
hold
can
these
read,
faster moving particles.
on a much longer
So maybe
chart.
that's why the Milky Way has very
It's
few
very
satellite
down,
galaxies.
and so
This
why
doesn't
wouldn't
really help us with
why
the
wouldn't
cusp
this
core
point
problem, but
be
here's a
relative to
proposal
this point?
that may.
Well, it's saying that it has higher value
Self-interacting
right
dark
now,
matter,
which could
SIDM,
phase
proposes
this one
that
to
dark matter
catch.
particles actually do
It could
interact
have.
with
This had
themselves
great
at big
value,
laws that
started to
standard
ratchet
CDM
down,
would
people
assume.
liked it, it wasn't just
That means
blowing
they
through the
can
floor,
repel and
they
scatter
throw it
off
up
each other,
and do
which
that.
stops
So
them becoming packed too tightly
in
above
physics,
a certain density.
it would
Finally,
require
there's also
a
quasi
heavenly
dark
body,
matter,
some
FDM,
kind of
which we
celestial
talked about
function
in
to be
our
like
recent episode.
FMA, that's
In
going to
this
do
model,
what it
dark
does,
matter is a superfluid
unless
of
I
ultralight
have it
axions with a
spectrumed
Debye
on some
wavelength
reason.
thousands of light years long. It can't
40
form
here.
substructures
I was like, that
smaller
could have
than this
plateaued off.
wavelength,
They didn't want
so
to.
neatly
They all
eliminate
washed it
tiny
off in the chop.
satellites, and they eliminate
And
very
all
concentrated
these
galactic
people
cores.
sold out
That's
right here.
solving
They got
both
risky,
missing satellites
popped it
and
down,
the cusp
drops
core
down.
problems.
People were
Okay,
still buying
so
in,
we have a
keep
few
pulling
reasonable
up.
solutions to our dark
So
matter
if it
woes.
was a black hole.
Which is right.
And it was doing that.
Well, not so
plus
emitting
While and
all of
intaking.
This new physics was being concocted, there was a
You'd understand why there's so many scientific diagrams.
Could be fixed.
Get rid of this, get rid of this.
Remember, CDM is
get rid of these, but keep this.
For more reasons than just its behavior as dark matter.
Yeah, hello world, it man.
That it is the most natural type of dark matter
to
have formed in the early universe. that theoretical convenience
when we look
isn't
through
enough for us
James
to
Webb
just accept CDM
and see that
if it doesn't
13
also
billion
explain our
to
observations.
20 billion
But it
year
turns
old
out that
galaxy,
despite hints to the
we don't really know
contrary,
where it is in
CDM
there.
may actually still be our best
That there's
bet.
an argument in
The CDM
cosmology about
simulations I've
that.
been talking
But
about
what we
so
know is
far
it doesn't
are
matter
dark
between
matter
that distance.
only,
If it
which
was a
means they don't
star,
include
before it
ordinary
went,
matter.
I'm
They're just
talking
simulating
something
how dark
so
matter
super
behaves in the
massive.
absence
And
of
later,
gas
if
and
you took
stars
it
and
back
all
even
that
farther,
physical
that would
stuff.
track you back to the
Now,
Big
that
Bang
sounds a bit
and decay.
forgetful on the
And
part of
well,
the
what do we know? There's
simulators.
iron
But
in
remember,
a star.
there's
There's
something like
obviously
5 times
lithium
more
in
dark
there.
matter than ordinary
I
matter
don't
in the
know what
universe.
you would call
Almost
those
all of
things,
the
but
gravitational oomph in the universe is from dark matter.
what not, you don't know
So
hidden
it's
variable
actually not crazy for these
is
simulations
dark
to
matter.
ignore the relatively piddling
I
contributions
can't see it.
from atoms.
I can't know it's there, but I can see it in the wave.
Actually,
We haven't got
are
a
now
name for
discovering
it.
that there are a couple of reasons
But we know
why
against our
ordinary matter
semi-imperial mass
really
equation,
does
it's
matter.
expanding.
First, ordinary matter is the stuff we actually see.
Like,
So when you're trying to use a simulation to
me,
predict
I'm never
what
going
it
to
is we
know
should see,
Fermilab here
it's helpful
is
to have
exactly
that stuff
doing.
in your
I'm uncertain.
simulation.
But I'm pretty
Otherwise,
sure
how
they're
do you
colliding
predict
particles
what
together.
you're going to see through the telescope. For example, we guessed that all of the dark matter subhalos around a system like the Milky Way
Can't be sure
should
that
contain
they're
visible
doing
satellite galaxies.
particle collisions.
But it turns out
But
to
as
be
you look
wrong.
at those chart
Subhalos
diagrams,
that are less than around 8
they're hitting
billion times
frames.
the mass of the sun are
It could either
simply
be what it
incapable
is,
of capturing gas
or
from
because of the
intergalactic
inverse square
medium.
law, the
Because
difference in
gas
that
is just
number
too hot,
determines
its particles move too quickly to become
that
trapped
thing.
in
So then
the
you go
shallow
looking around.
gravitational
Once you
whirls
observe
of
it,
these
oh, it was that
low-mass
comet. It stops being
subhalos.
dark matter.
So
And it
most
starts
of these
being matter
subhalos
that's
have
factorable
stars,
to
and therefore
correct
we
that
can't
equation,
actually see them.
which
If this is
expands
right,
our
then
own.
the
We
satellites
need
aren't
expansion.
missing,
Without expansion, you
they're
don't have
just
elements.
invisible. Also, our telescopes are becoming more and more sensitive, and we're starting to see a lot of very faint structures and substructures. So we're getting closer to
Except
the
for
actual predictions
it's
of
doing
the CDM
this.
models.
You know,
And
it
now
actually
the second
kind of
reason
has
the
this
regular matter matters.
line to it that
Although
gives it an
so-called
equator.
baryonic matter
Except for
represents
its
only a
spin,
small fraction of the mass of the
acting
universe.
right-handed or
This stuff
left-handed
is
today.
way more interesting than dark matter
And
because it
two
can form
positive
us, for
is
example, but it can
an
also
indicator of
influence
strong
dark matter in
right-handed. How do you do it?
unexpected ways.
Strong prime.
Because baryonic matter can form
left-handed
stars, it
prime
also
so far
produces
as an operator
supernova
that
explosions
in a
when the
normal
most massive
operation
of
of
those
dropping
stars
10
die.
numbers or
Every
5
time a
numbers or
supernova goes off in a
compensating
galaxy, it blows
over
away
a week,
huge chunk of the gas surrounding
you
it.
know, a little
That
bit of gas
could
or
be
because it's
forced out
dripping.
of, say, the galactic
dripping?
core,
Yeah,
or
yeah.
even out of the galaxy entirely. And this outgoing gas drags a little bit
Well,
of
it's not
dark matter with
dripping,
it.
it's just
The
emitting.
dense galactic
We just don't have a
core of
name
young
for it. It's a
galaxy
fluid on the
will
ground. I
experience
don't know where it's
burst
coming
after
from out of the
burst
loader.
star formation,
And
which leads to multiple waves of supernovae.
it weakly interacts
Over time,
with the
quite a
transmission,
bit of
right?
dark
Or
matter
the
can
motor
get
knocking,
dragged
and then you chase
gravitationally
that down,
out
and
of the core
well, it's
of
not
the
an
galaxy.
oil leak. It
This
was
can
actually a
ultimately
cracked cylinder
flatten
or
out
something,
what
right?
started as a very high density core, eliminating the cusps predicted by the CDM model. But CDM isn't totally out of the woods yet. In recent years,
I was like, we
found
see those
some
numbers in
counterexamples that
quasars,
seem
man.
to defy these fixes for CDM's problems.